The comment sections on our videos about mysterious star forts are always a battlefield. But recently, the debate has shifted from the walls to the weapons. The artillery of that era seems like a collection of engineering contradictions. Observant viewers raise questions that, at first glance, seem to stump official history. The biggest paradox concerns the material. Why were cannons mass-produced from bronze? Everyone knows bronze is a copper alloy, relatively soft and malleable. How did these barrels not tear apart when the gunpowder ignited? Why did engineers ignore harder iron? It seems like technological nonsense. Just as strange is the lack of sights on many ancient guns. How did gunners hit distant targets without a sight or scope? Was it just blind luck? And why use primitive round cannonballs instead of aerodynamic pointed shells? Some museum pieces even have rectangular or flattened barrels. Were they shooting bricks? Admittedly, these inconsistencies are puzzling. While standard historical explanations exist, many people have lost faith in academic history. This has fueled wild theories. Maybe these weren't weapons at all? Some believe they generated light beams or sound waves to shatter walls. I wanted to get to the bottom of this, not by guessing, but by looking at original documents and engineering notes. But before we dig into this investigation and bust some myths, make sure to subscribe and hit the like button. It helps the truth reach more people. Before we analyze the guns, we need to settle the debate about the forts they defended. Skeptics often ask, where are the blueprints and budgets for these massive star forts? Surely they couldn't be built by ordinary people. The truth is, information exists in old treatises, including calculations. The problem isn't a lack of data. It's an expectation that a receipt for bricks from 300 years ago should still be in a file somewhere. Even today, construction records aren't kept forever. Expecting 400-year-old paperwork to survive is naive. Then there's the geography. Updated maps show star forts all over the Americas, which some claim contradicts history. But if you look closely, most North American forts are on the East Coast, perfectly matching the timeline of colonial expansion. The dates, like the Quebec fortress in 1673, fit perfectly with the era of the famous engineer Vauban. We also need to address the myth of perfect symmetry. Satellite images are often used to claim these shapes required impossible technology. But in reality, perfect geometry wasn't the goal. Look at Fort McHenry. From space, it's clearly not perfectly symmetrical. For a fortress designed to withstand siege and provide crossfire, mathematical perfection wasn't necessary. Functionality was. Enthusiasts often mark any enclosed wall on a map as a star fort, lumping simple Australian outposts or Angolan castles together with European masterpieces. In reality, we see engineering adapting to the landscape. Textbooks like The General Experience of Fortification taught engineers how to calculate angles and distances. This was science, not lost magic. Now that we know the forts were real, built by humans using blueprints, it's time to look at their main argument: the artillery. The biggest puzzle for modern skeptics is the manufacturing capability. How did masters in the 17th century create such heavy, symmetrical objects without electricity, CNC machines, or lasers? Looking at the smooth barrels, it's easy to believe in lost ancient tech. But the reality is more grounded, and honestly, more impressive. The answers lie in rare technical manuals, like artillery memoirs. The process didn't start with metal, but with wood and straw. The core of a future cannon was a spindle, a long, straight spruce log. This wooden base was greased and wrapped tightly in straw rope. The straw acted as a shock absorber and added volume. Over this, they applied layers of clay mixed with brick dust, wool, and even horse manure for binding. This formed the model of the cannon. But how did they get the shape right? They used an analog ancestor of the lathe. A profile board, a wooden template with the cannon's exact outline cut into it, was fixed next to the rotating spindle. As the spindle turned, the board scraped away excess clay, shaping the model perfectly. Once dry, it was coated in fat or wax, then covered in a final layer of clay, the jacket or mold. When heated, the straw and wood burned away and the fat melted, allowing the mold to separate from the model. To make the barrel hollow, they inserted an iron core wrapped in wire and clay, centered perfectly with metal supports. Molten metal was poured between the outer mold and the inner core. What seems impossible today was actually a sophisticated multi-step algorithm where every material, from straw to fat, played a specific physical role. It wasn't magic, it was the pinnacle of craftsmanship. Skeptics often argue that old books are just fantasies and that these processes are impossible to replicate. But the best proof is practice. A group of researchers in Sweden, supported by the Vasa Museum, decided to find out. They didn't just build a computer model, they physically recreated a 17th century naval gun. Using the exact impossible methods described in old texts, blacksmiths and foundry workers cast a full-sized replica, a monster over 7 meters long. This tested not just the casting method, but the metal itself, which many claim is too soft for artillery. They even built a replica of a ship's gun deck to test the environment. The goal was to measure shock waves, noise, and smoke, things you can't calculate on paper. The moment of truth came with live fire. They loaded the gun with real gunpowder and fired. The result? The cannon didn't explode. The barrel withstood the massive pressure. The bronze alloy, theoretically too soft, proved to be incredibly tough and durable. The experiment proved that the blueprints weren't lying. These primitive devices were functional, terrifying weapons. But while production is explained, another mystery remains. How did they aim? With no sights on the barrel, hitting a target seems impossible to modern eyes.
Этот шведский опыт наглядно доказал, чертежи не врут. Технология литья с использованием глины, соломы и воска позволяет создавать надежные артиллерийские системы, способные вести огонь. Миф о том, что официальная история скрывает невозможность производства таких орудий, рассыпался под грохот реального выстрела. Но если с производством и прочностью вопрос можно считать закрытым, то остается другая загадка, волнующая умы. Как из этого оружия можно было куда-то попасть? Ведь на большинстве музейных экспонатов мы не видим ни мушек, ни оптических прицелов, что кажется нонсенсом для любого, кто хоть раз держал в руках винтовку.
The lack of sights is a favorite argument for those who think these were sound weapons. How can you fight if you can't aim? But the answer lies in ballistics. Cannons didn't fire in a straight line like a laser. They fired in a parabolic arc. The projectile was a heavy physical object affected by gravity. To hit a distant target, the barrel had to be angled up. Looking down the barrel was useless because the muzzle would block the view of the target. Instead, gunners used math and mechanics, quadrants and wedges. By driving a wooden wedge under the breech or turning a screw, they adjusted the angle of the barrel. Mortars, designed to shoot over walls, had no sights at all because they only fired in high arcs. Another myth is the ammo. Movies show only round iron balls. But 19th century manuals reveal a terrifying variety. There was chain shot, 2 balls connected by a chain that spun through the air, shredding sails and masts. There were carcasses, incendiary shells that acted like napalm. There were even flares. But the most common anti-personnel weapon was grape shot, essentially turning the cannon into a giant shotgun. A canister filled with lead bullets would burst, spraying a hail of metal. It was devastating against infantry. However, a round barrel creates a cone-shaped spray. Since enemy soldiers stood in wide, horizontal lines, a cone pattern wasted bullets into the sky and dirt. Engineers tried to fix this efficiency problem, leading to the creation of some true mechanical monsters. War demands efficiency. To solve the problem of the cone of fire, engineers created some of the strangest guns in history. Cannons with oval or flattened muzzles. Mystery lovers see these and imagine they fired energy disks or bricks, but the truth is pragmatic. In the mid-18th century, the Russian Empire developed the secret howitzer. Engineers realized that to hit a wide line of soldiers, you needed a wide spray of bullets. They flattened the barrel into a horizontal slit. This forced the grape shot to spread out like a fan, drastically increasing lethality. This project was top secret. The barrels were covered during transport, and leaking the design was punishable by death. However, physics intervened. The flattened barrel couldn't fire standard round cannonballs, making the gun useless for anything other than close-range support. In 1758, the Prussians captured some of these guns. Frederick the Great mocked them as the Russian secret, yet later tried to copy the idea himself. Then there are the bent barrels you see in old photos. They aren't damaged. They were designed that way. In the late 19th century, inventors tried to create disc-throwing guns. The curve was calculated to spin the disc as it exited, like a frisbee. While they had impressive range, accuracy was terrible. These weren't alien artifacts, but dead-end experiments in the search for the perfect weapon. But if the shapes are explained, why did they stick with bronze instead of harder iron? The material question is a classic trap. Iron is harder than copper, so bronze cannons make no sense. This logic fails because it confuses hardness with toughness. In artillery, you don't need a metal that resists scratching. You need one that handles explosive shock. Cast iron is hard but brittle. Under sudden pressure, a cast iron barrel with a minor flaw shatters like glass, killing the crew. Bronze, however, is viscous. Old engineering notes explicitly state that bronze is tough like forged metal. It can expand slightly under pressure and return to shape. In a worst-case scenario, bronze would bulge or split, but it wouldn't explode into shrapnel. It was a safety feature. There was also a logistical reason. To make a cast iron gun safe, the walls had to be incredibly thick and heavy. Bronze is stronger under tension, allowing for thinner walls and lighter guns. Calculations showed that 625 pounds of bronze could do the job of 1,000 pounds of iron. When dragging guns through mud with horses, that weight difference won wars. Bronze wasn't a sign of backwardness. It was a calculated engineering choice. Among the surviving oddities, there is one that looks truly alien, the so-called udder cannon. With strange bulbous pockets along the barrel, it looks like something from a sci-fi movie. These aren't energy capacitors, but evidence of a desperate attempt to cheat physics. In the late 19th century, engineers like Louis Perot and the Americans Haskell and Lyman wanted to solve a problem. Gunpowder burns up instantly in the breech, meaning the shell stops accelerating halfway down the barrel. They decided to turn the cannon into a multi-stage rocket. The udders were extra powder chambers. The theory was that as the shell passed each pocket, the hot gas would ignite the extra powder, giving the shell a fresh boost of speed. On paper, it was brilliant. In reality, it was a disaster. They underestimated gas dynamics. The hot gas moved faster than the shell, rushing through the tiny gap between the projectile and the barrel wall. The extra charges ignited too early, in front of the shell, acting as a brake rather than a booster. Instead of a superweapon, they built a gun that fired slower than standard cannons. It was a monumental failure, forgotten until the Nazis tried again with the V3. It's a monument to human error, not alien tech.
Эффект оказался катастрофическим. Дополнительные заряды не разгоняли снаряд, а наоборот, тормозили его. Испытания показали удручающую начальную скорость в 335 метров в секунду, что было значительно хуже показателей обычных классических пушек того времени. Проект, на который возлагались огромные надежды и тратились колоссальные средства, обернулся полным провалом. Инженеры были вынуждены признать поражение перед неумолимой газодинамикой. Технология многокамерных орудий была забыта почти на полвека, вплоть до экспериментов нацистской Германии с пушкой В-3, но это уже совсем другая история. Таким образом, пушка с выменем — это не артефакт древних богов, а памятник человеческой ошибке и тупиковая ветвь эволюции, доказывающая, что путь к совершенству услан не только победами, но и грандиозными неудачами. Однако в истории остался еще один гигант, который, в отличие от пушек Хаскела, стал символом не провала, а мощи, хотя его боевая биография вызывает не меньше вопросов.
The final piece of our investigation sits in the Moscow Kremlin. The Tsar cannon. A giant that holds the record for caliber, yet is famous for never firing. The huge cannonballs stacked next to it are fake, decorative cast iron from the 19th century that would tear the gun apart. This fuels the myth that the cannon itself is a fake. But documents from 1586 tell a different story. The master caster, Andrei Chokhov, didn't call it a cannon. He called it the Russian shotgun. This explains everything. It wasn't built to fire solid balls at walls. It was designed to fire stone grape shot, huge sacks of rocks. Imagine a 40-ton shotgun aimed at a river crossing. One shot could wipe out an entire attacking army. Chemical analysis of the barrel found traces of gunpowder, proving it was fired at least once during testing. However, its true purpose was psychological. It was a weapon of mass intimidation. Foreign ambassadors seeing this bronze monster reported back that Russia had the technology to cast and move such giants. It was a deterrent, like a nuclear weapon today. The Tsar cannon fulfilled its mission without ever firing a shot in anger. It wasn't a bluff. It was a sleeping giant. We have walked a long path from straw molds to bronze giants. This investigation shows that behind every impossible artifact lies not magic, but human genius and hard work. Ancient engineers didn't have lasers, but they understood materials and physics better than we give them credit for. The history of artillery isn't a tale of lost Atlantean tech. It's a story of trial and error. We saw how they solved problems, flattening barrels to spread fire, using bronze to prevent explosions, and using math to aim without sights. Even the failures, like the multi-chamber gun, show a brilliant, if flawed, engineering process. It's tempting to believe in sound weapons or ancient lasers because it makes the world feel magical. But the reality that our ancestors could cast 40-ton shotguns and calculate trajectories with a pencil is far more impressive. Physics and chemistry of the past aren't boring, they are fascinating. Don't look for lasers where there is beautiful, brutal engineering. Reality doesn't need to be embellished. If this deep dive helped you look at history with fresh eyes, please hit the like button. Let me know in the comments which impossible artifact we should investigate next. And don't forget to subscribe so you don't miss the truth.